Yes, Algebra 2, Lesson 4-2, divide quadratic by linear expressions. Today's date is Friday, October 30th, 10/30/2020. The day before Halloween, for the record, for the video record, I'm wearing Tony the T-Rex. Objective, Jade, go. There it is. And long division, as you might remember, is kind of tedious. We'll go a little bit slow to make sure we have the thorough understanding, but we have a lot of stuff to get through. Like we have all this stuff and we have problems on the back. So long division, 11 goes into 136 how many times? Another way of saying this problem, by the way, is what is 136 divided by 11? When you have a fraction like this, you make your long division like this. You set it up like this. How do I begin, Charles?
You would see how many times 11 goes into the first number, which doesn't. And then the first and the second number, which is 13, goes into the 1, so you put a 1 in the first.
Perfect.
And then 1 times 11 is 11, so you put 11 in the 13. And then that, and then you would subtract that, and it would end up being 2.
Or 2, no, you're right. 2. Okay, I'm gonna do next step for someone else. But this process of long division, we have to do this with polynomials in a sec. So really make sure you have a perfect understanding of what's going on here. What is the biggest thing that went into the first number? Nothing. Expanded to 2 numbers. Okay, now it goes into it. I write the number above the last number that it went into. I do this 1 times that 11 to get 11. And then I multiplied everything that's right here by a negative. I add them up. 13 plus negative 11 is 2. And then I repeat the process again. Jade. Okay, then what's our last step? Someone else. What do we do with this for? And for the sake of, we don't want decimals here. Decimals are awesome, but for our case, we want a fraction at the very end. What do we do with that fraction, or what is the fraction? Yeah, Andres.
Wait, wouldn't the remainder be 4?
Yeah, so we say 12 remainder 4, right? Yeah. And the way that we say that as a fraction, though, is what?
12 and 4/10.
4 over whatever this number was. 4/11. Yeah. So the answer here is 12 and 4/11. Jade.
Oh, well,
You concur with Wyatt? 4/11. All right. So now we're going to do this with a polynomial. We'll take our time. And example 1 is going to take a while. So we'll do this. Okay, so x plus 1 goes into x squared how many times? And you'll say, hey, that doesn't work because there are 2 terms here and there's 1 term there. That doesn't quite work. So let's go ahead and expand it into how many times does x plus 1 go into x squared plus 3x? Does it go into it x many times, x squared many times, 3x many times? What do I need to multiply this x squared plus 1 to match up with this first term? That's another way of asking the same question. Jose? By x. And I write that above this term, x. Again, you're really trying to get rid of this first term. What do I need to multiply this entire binomial by? What 1 term do I multiply by in order to get this x to an x squared? The answer is x. When we do that, Jose, we're left with what? X times x plus 1 is plus 1x. Yeah, or just plus x. And I'm going to pause here to 1, remove my sweatshirt because I'm overheating in this thing, and 2, to make sure you have enough time to understand the 3 steps that we just did there. It looks like we've done very little writing, but there were 3 steps. Okay, what are we doing next then? 2 people have an idea? All right, what?
I think you would subtract x squared plus x from x squared plus 3x.
Yes, so another way of saying that is we kind of multiply everything here by a negative, so it turns into a negative x squared minus x. Or you can say it your way. As long as you can remember each of these terms is being subtracted, then you're in the clear. So we're subtracting each of them, and I get what, Wyatt?
2x.
2x. And again, that is correct because these two terms should have canceled out if you did it correctly. If you did something incorrect, you will still have two terms here. So those two terms cancel out. That was the whole point. That's why we multiplied by x to begin with, because x times x is x squared, and we can cancel that out. All right, someone new, someone brand new. What do we do? And if it helps, pay attention to what we did on the left-hand side. Notice the similarities. The coefficients are 1, 3, 6. The coefficients are 1, 3, 6. The coefficients out front, 1 and 1. Coefficients out front, 1 and 1. This is basically the same problem. I've just turned it into a polynomial. Right now, we're at the step where we just did 13 minus 11, we got 2. X squared plus 3x minus x squared plus x is 2x. So we have that 2. What was the next step after getting that 2? Jenny? Bring down the plus 6. Bring down this plus 6, so I say 2x plus 6 now. That is the next step. Okay, and then I do that process again. What do I need to multiply x plus 1 by to get rid of this first term? Someone new. Sorry, Wyatt. Sorry, Jade. Sorry, Charles. Sorry, Jenny. Someone new. What do I need to multiply this x plus 1 by, specifically that x by, to get rid of this 2x? Yeah, Jessica. 2. So say a positive 2 or negative 2? Positive 2. That'll match it up. Yeah, plus 2. So 2 times the x plus 1, Jessica, is? What is 2 times x plus 1? Be careful. 2 times 1? 2. There it is. And this does match up. The 2x and 2x matches up. So as Wyatt has said, you subtract the second term from the first term. Or another way of saying that is I make both of them negative. I multiply by a negative. All right, what do we have now? Again, someone new, someone that is brand new, that has not spoken yet. Subtract those terms. Cohen, go. X plus 4. You're really close. 2x minus 2x. There's nothing left over, though. Those are gone. Just before, exactly. Just 4. Those cancel out, and I'm left with 4. And my final step, I have this remainder of 4, just like I have the remainder of 4 down here. What do we do with that 4? Again, someone new. I'm going to get everyone new in. Andres.
You make it into a fraction, and the fraction would be 4 over x plus 1.
4 x plus 1. And I'll add those. So plus 4 over x plus 1. And I could probably add them over here too if you wanted. And there's our answer. If I had x squared plus 3x plus 6 divided by x plus 1, the answer is x plus 2 plus 4 over x plus 1. Look at the similarities between the left and the right. They're the same thing, only one's a polynomial and one is not. Well, I guess it technically is, but it's more numeric. There's no x's, there's no variables. One has variables, one does not. That's a correct statement. Are you guys ready for a hard one? Ask a question then. If you're not ready, ask a question, a clarifying question. How did you do that step in blue? How did you get that step in orange? Andres?
How did you do that step in blue? Yeah.
So the first step is, how do we get rid of this x squared? How do I get x squared? From this x plus 1, this x will turn into an x squared if I multiply by x. I'm trying to match this term here. X times what is x squared? X times x is x squared. Once I get this number, then I multiply x, and I distribute it into both of these two terms. X times x, x squared. X times 1, x. You're always trying to match up what the first term is. Once you get rid of that term, then you're trying to match up with the next first term, which is going to be 2x. 2x. How do I get 2x from x plus 1? Specifically, what do I multiply the first term by? X times what is 2x? 2. good question. Another question?
You simplified that.
Okay, well, you're welcome. Thanks for asking the question. Let's try another one then. Example number 1. I have the fraction, so I'm going to set it up. Notice that my denominator is nice and small, which means this number to the left of my equation, or my, does it have a symbol name? I don't even know. I'm going to have x plus 3 on the left. And give yourself some room up top, because remember, that's where the answer goes. So don't write on this line. Go and skip down a line. So my new problem is x minus 3. And that's going to go into 3x squared minus 4x minus 19. There's something very important that I'm not doing in this example. I changed it from my first year of teaching because I made it too hard. But if I had something like x to the power of 4 or x to the power of 3, and then skip down from 3 to 1, you have to leave an empty space for each degree. This is a degree 0. This is a degree 1. This is a degree 2. If we had to skip one, pretend I didn't have that 4x there, if that 4x didn't exist, this 4x didn't exist, I would write minus 0x, because it needs to be a placeholder. This will become clear when you start working on the homework, but I'll just give you the warning. Every single space in here is for a specific degree. If you've gone from a degree 3 to a degree 1, you skip degree 2. You need to leave an empty space for every single degree. Because all the degrees are here and we haven't skipped any, we're okay. So I'm going to continue on with this example. Hopefully I'll have something on the back. Do I have a future example that skips a degree? I do. In example 3, I skip a degree for you. So you've been warned. Yeah, question, Andres.
Wait, so if it was 3x to the power of like 5, and then 3x and negative 4x to the power of, oh wait, no. If it was, okay, if the first one was 3x to the power of 5, would the rest have to be like negative 4 to the power of 4, then?
No, so let's just make that change. Then the problem would look like this. This is a great question. If this was the new problem, it would be x minus 3 going into 3x to the power of 5 plus 0x to the power of 4 plus 0x to the power of 3 plus 0x to the power of 2 minus 4x to the power of 1, which is just 4x, minus 19. That's how the problem would look. Great question. Great what if scenario. You need to leave placeholders for every single degree. And you'll see one of those on the back. So don't worry, you will see an actual example. Okay, now it's basically this example over here on the right, top right. How do I begin? Charles.
Multiply, so the first 2 terms, you multiply it by x, roughly, yeah, so you put an x up there.
Okay.
And then it would be x squared on the left minus
3x. All right. So everyone see what Charles has done. He said, if I multiply by x times x minus 3, I get x squared minus 3x. And then when I subtract these, this one should go away, and I'll get some number over there. And I see Charles sees his error. Fernando's giving him a thumbs down. Charles, fix your own error.
Do I need to multiply by 3x?
By 3x in this case, yes. Tell us why.
Because the first term is 3x squared. And you have to do
Exactly. You should match this first term exactly. X times what is 3x squared? X times 3x is 3x squared. And then distribute into this right term, these two multiplied.
and that would be 12x.
Be careful, 3 times 3?
Oh, 9x.
9x, there it is. Okay, so now this is a correct first step. Now what? And I'm waiting for people to finish writing so they have time to think. What do we do next? Look at your problem up above. And for those of you that don't have notes, here's the problem up above. Wyatt.
You're going to want to subtract the 3x squared minus 9x from 3x squared minus 4x, or like you said, multiply it by a negative. So
So,
when you do that, you're gonna cancel out the 3x squareds on both of those, and you're gonna be left over with a positive 5x, because when you subtract a negative from a negative, then that becomes a positive, so 9 minus 4, 9 plus negative 4 is 5x, so you're left over 5x.
there it is. And I want to make sure everyone can see that. Essentially what I'm doing after I make sure that these two terms match up is I switch the signs. If this was a positive, it becomes a negative. If it was a negative, it becomes a positive. I switch the signs or multiply everything by -1 because really we're trying to accomplish the goal that Wyatt laid out. We're just trying to subtract this term from our original term. What is black minus green? When I am doing minus green, I'm really distributing a negative. That's my little trick for you guys. If you don't like that trick and you just like thinking, oh, just subtract them, then you're good. All right, so far we're correct. What's our next step then? Andres?
Just bring down the negative.
Bring it down, yep. So bring down the -19. I should probably use the same color, orange. And you get -19. There it is. Do you want to do the next step as well?
Yeah, I'll think of someone else.
Okay. What are we doing next? Jose? Five? Yeah, tell us why it's 5. Yeah, okay. So distribute the 5 with our binomial over here to right down here. 5x minus 8 or 15? Okay, sorry, didn't hear you. These masks make it hard to hear and speak. All right, this is correct, and I'll make sure that everyone has that understanding. What times x is this orange 5x? And Jose told us the blue 5 times this x is this blue 5x to match up. Okay, now that we've matched it up, what do we do? Fernando.
Multiply those numbers by a negative,
Yep.
and that'd be -5x plus 15. And then you cancel out the 5x's, and you're left with -4.
-4. And we're almost done. What's my final step? I think it's between Sergio and Josie. Josie. There it is. And I hope that you only use the left-hand side because I want to show you something that's going to happen kind of cool over here on the right-hand side. What happens if we actually multiply these two numbers together? This 3x plus 5 times x minus 3. I want to see what happens. X minus 3 times 3x plus 5. Well, I mean, technically, I should be doing x minus 3 times 3x plus 5 minus that 4 over x minus 3. But I think that you guys can all see when I distribute x minus 3 times this -4, x minus 3, it's really just saying do all of that stuff and then just subtract 4. Again, what happens if I multiply x minus 3 times -4 over x minus 3? I'm going to have an x minus 3 on the bottom and the top that are going to cancel out, and I'm left with just the -4. It's not super important. I'm just showing you that I'm checking my work. This does work. Yeah, what?
So which one would you put in the category of the final answer?
Oh, this is the final answer. We've done our final answer. I'm checking our work now. We can box it. This is our final answer. Let's check it. Oh, actually, this is a, I have to check what time we're out of here before I forget. Bell schedule, we're out of 6th period, 12:10. I got 15 minutes. Okay, I think I'm gonna go ahead and skip this. It's not that important, and I can come and talk about it another day if I need to. Let me talk about the shortcut, because that was a lot of work. You can all nod your heads. Long division kind of stinks. There's always a shortcut for all of math. And sometimes the shortcut is hard, sometimes it's easy. Today, it's easy. Woohoo, we celebrate, right? It's called synthetic division. Synthetic division only works with certain types of dividing problems. It only works when dividing by a linear term meaning x plus or minus something. It does not work for x squared, x to the -1, x to the power of 4. All of those things it doesn't work for, but if it's just a normal x to the power of 1 that is a linear term. And it has to be a leading coefficient of 1. It can't be 2x. That doesn't work. It can't be 3x minus 4. That doesn't work. Only when it's x plus or minus some number. So things that are good, x plus 1, x minus 5, x plus 10. If that is the denominator, if that's the thing I'm dividing by, all of those have a shortcut, and it's called synthetic division. You guys want to do the same problem that we did last time? Just to check that it works? So I'm going to be doing this problem up here. How do I do 3x squared minus 4x minus 19 divided by the quantity of x minus 3? So the way that synthetic division works is you take that bottom number here, that minus 3, you take the opposite of that, so it's going to be positive 3, and then I'm going to put it in a box. So the general way that this is going to work, that was all my notes. Too much of a line was used there. So I'm going to do in the top left up here a positive 3. I switched the sign of the denominator. If it was, I can zoom out, maybe too far. Zoom back in, computer. If my denominator was a positive 7, then I would put a negative 7 down here. If it was a negative 10, I would be a positive 10 down here. You just switch the denominator. From there, you list the coefficients of each of the thing I'm dividing by. So in this case, I have coefficients of 3, -4, -19. Just the coefficients, just the numbers. So I'm going to write 3, -4, -19. Again, if I had a placeholder, if I skipped a value, I would have to put a 0. You'll see that at the very end, the very last problem that we have, example 3. All right, synthetic division is ready to go. You have set up the problem. Now it's time to actually do the math. Time to actually complete the synthetic division. Before I do that, though, does anyone have any questions on where these numbers came from? Mr. Sindel, where did you get positive 3? Where did you get 3, -4, -19? Any questions like that? Fernando. The what?
Where did you get them?
The 3?
Yeah, where did you get the 3?
The 3. So the 3 came from the denominator. It was -3. I switch the sign and it becomes positive 3. Whatever I'm dividing by, switch it, it goes in the top left. If this was a -10, I would have had a positive 10. If this was a positive 7, I would have had a -7.
So what about that 3 outside the box? At the bottom of the box.
3 out. This one? Or this one?
Yeah, that one.
This 3 is the coefficient. 3, -4, -19. That 3 is this 3. 3, -4, -19. They're the coefficients of the numerator. Okay, good question. Any other questions? Okay, here is your first step. First step is to bring down the 3 and it just goes beneath the line. I'm gonna write numbers here and here, so be ready for that. The next step is I'm going to bring the 3 up and diagonally to the right, and I'm also going to multiply by whatever number I have here. 3 times 3, and we all can shout out, is 9. Woo. Okay, then I just keep adding straight down. -4 plus 9, you guys will all shout out, is 5. Again, whenever you go across the line diagonally to the right, we multiply by this number up here. 5 times 3 is 15. Add straight down, you guys will shout out -4. And there's our answer. This last term is always going to be your fraction. Your fraction is going to be -4 over x minus 3. This is always going to be a number, your integer. This is always going to be an x. If I had another number, it would be x squared. Another number would be x to the power of 3. So in this case, I have 3x plus 5 minus 4 over x minus 3. And if we zoom out, the drum roll, please. Check out how those are the same answer. That is a great question that no one has ever asked me, and I assume the answer is yes. Should we try it? Oh, we are running out of time. We have 10 more minutes left. Can someone remind me to do that later?
Yeah.
Example number 2, let's try it. You can either use synthetic division or long division, and I'm gonna take a guess that you want to use synthetic division because it's easier. All right, someone help me set it up. What number goes in the top left? Sergio, you haven't spoken yet. Yes, a positive 2, and that's going to be in a little box so that I don't remember, or I don't confuse that for a coefficient. What are the 3 numbers that go out to the right of 2, Charles?
2 plus 3 minus 10.
There it is. I draw my line underneath. Andres, what's my first step?
All right, so first you're gonna multiply 2 by, wait, what?
Just bring the
Oh, you
2,
bring down the 2,
2, and then it.
and then you multiply by 2, which is 4.
What? Do the next step.
Add 3 and 4 is 7. Bring it up, multiply it by 2, which is 14. I'll make it going.
I'll do someone else for the last step. Jade, last step.
And then you're gonna add negative 10.
4. And where's my answer then, Jade? That last one is always a fraction, so it's going to be 4 over 2. Yeah, that original denominator. This is going to be 7 or 7x. And then this is going to be 2 or 2x. 2x. There it is. 2x plus 7. And then if there's no sign, you assume it's plus. Don't know who they are. And there's the answer. We're done. 2x plus 7 plus 4 over the quantity of x minus 2 is our final answer. Andres?
So you wouldn't keep the code or the variable for term, or like for numbers, like 3x, you just take it away?
Just get rid of the variables. Yep.
What about the first one, x squared?
2x squared, just turn it into 2.
Wait. What about the 2x? Like,
The 2x, where is it? Oh, this 2x right here?
yeah.
Well, that's our final answer. Remember that this one is always going to be a fraction, a number divided by a number.
Oh,
This one is always going to be just the number. This one's going to be x. This one's going to be x squared, and it keeps on going forever and ever to the left.
oh.
All right. And then I'll help you set up the last one, and then you guys have to solve it on your own. I'll help you set it up because I promised you I would give you a term that I skipped. We have 6.5 minutes left, which means I might have time to come to Jade's question. All right. So the number that goes in the top left is what? And I'm waiting for the people that haven't participated in the last problem. Jose. -5. That is the number that goes in the top left. What are my coefficients? And this is the trickiest part of the problem now. What are my coefficients? Someone that didn't do the last problem. And sorry, Jose, you already helped on this one. Jade worked on the last problem, sorry. Someone that didn't work on the last problem. What are my coefficients? Sergio. 1 plus 0 minus 20. That was the trickiest part. We had a placeholder for the x value. This is the x squared value. That's the x value. That's the integer value. Good job. I didn't trick you. And then I do a line. Again, someone that didn't do the last problem. Help me out. Oh, question, Charles.
So how do you know which one is the x squared value and the x value?
This one says x squared, and I'm missing an x.
Oh, okay.
Yeah, good question.
Whatever the power of the first one is.
Exactly, yeah. Yeah, so if I had like x cubed minus 30, which ones would be the 0? Would it be the x cubed, the x squared, the x, or the new integer, Charles?
There would be an x squared that's 0 and an x.
There it is, nice. Okay. I'm thinking it's kind of like that side of the room-ish that needs to help me out with this one. What do I do with that one? Andres, did you help with the last problem?
I don't know.
Oh, okay, I'll just call on you because I forgot. What do you do with the one?
You bring it down, and then that'd be 1.
1.
And then you just multiply by -5 and bring it diagonal that way, which is, yeah, -5.
Perfect. And I think you did do that last step, but now it's redemption. You got it correct now, right?
Yeah.
Perfect. Okay, so someone else from over here. Josie, Jessica, Jenny, Fernando. Help me out. What do I do with synthetic division? Yep, I add them straight down, -5, and then I do what with it? And you get? Perfect. Someone new. Someone over there. The 3 girls. The triad. Sorry, you're not a girl. Oh, I mean, if you identify as one, I apologize. Add them straight down. Jenny. 5. Perfect. Okay, and our final step between Jessica and Josie. What is our actual answer? Pay attention to the last problem. What do we do to that final problem? Between Jessica and Josie. Go for it, Josie. Good. Is this -5, -5, or is it a -5x? No, it's just the normal number. It's just -5. And then Jessica, what must this first term be? Is it 1, 1x, or 1x squared? 1x, yeah. All right, there it is. And then we can write out our final answer. We had 1x, or just x, -5 plus 5 over the quantity of x plus 5. Final answer box it. You may begin on your homework. And I want to answer Jade's question now. What happens if you just did synthetic division on a normal number? Should we just do this first one because we know the answer? 136 divided by 11?
Yeah.
So that would be -11, 1, 3, 6, shrink. 1 comes down, 1 times -11 is -11. I get -8. It doesn't look like it's working. -8 is 88. 88 plus 6 is 74. So, oh yeah, 94. I don't know what I was thinking. Why did that not work though is the high level question, right? We did -11. Oh, because it's a number that's, so technically what I have here is x plus 1. So you have to be careful about how you divide up your terms, because if you did something like this, if I did -1 and 136, I think it might work. Question?
Is it the same one or is it?
Yep, that's the one we're doing. There's an intro and then there's an actual one. I didn't make the same mistake as last time. Yeah. Thank you for correcting that. So -1, so 1 comes straight down. 1 times -1 is -1. That's going to be 2. That's going to be -2, and that's going to be 4. So the answer is going to be remainder of 4, or 4/11ths, and then 12. 12 and 4/11ths. Is that what we got?
Yeah.
12 and 4/11ths. Okay, so it is, but it's hard to adapt. For example, it will only work with numbers that are 11 through 19. Just the same rules that apply to synthetic division. The leading coefficient or the leading tens place needs to be a 1, and then there has to be a number. So 11 through 19 will work with synthetic division. Yeah, great question, Jade.